Hello everyone, today let's solve the problem number 208, implement the trie, nothing but the prefix tree, right? So what the question states here, we need to implement a trie or the prefix tree supporting three operations. What are those three operations? One is insert, you can clearly see here, this one insert. This is nothing but the initialization part. This will always be, return value will always be null. So insert of word means we have to add the word into the trie, right? So this one is, second one is search. We need to check if the full word exists in the trie. Again, I'm just repeating, we need to search whether full word exists in the trie, right? So just keep this in mind. So we have to add the word into the trie. We have to check if the full word exists in the trie. And the third one is starts with. So basically what this starts with do, we have to check if any inserted word starts with a given prefix or not. Simple, very simple, right? So let's go with the first example. They have given only one example here. Let's consider the same example man for the approach, right? So just give me a second, 1 second here. Just give me 1 second. Yeah, 1 second, man. Yeah. So I have considered this example, right? So now we have this one. First we have try. First thing that I have to tell you here is one thing. Just give me a second here. Mm, yeah, this one initialization part is always null. Just remember this one, right? Also, this one insert part is also null, right? So insert and this one initialization, both the return value of both are null. So this one and this one is null and this one is null. So this one here, see, we return value is string and return value is boolean. For this one also return value is boolean, right? So just keep this in mind. Yeah. Now let me consider the example one. So this one, let's consider example one. So now what we are doing, we are inserting the apple into the trie, right? Apple into the trie, and trie now has path. This one a, this is fine. This one is p, this is fine. This is also p, this is also fine. And this one is l, this is also fine. Finally this one is a. I don't have space here, so I'll just write here itself e, right? So this one, now we have inserted apple, this one to the trie. This is fine. So the return value will be still null itself, right? So this is the insert. So as I've said, initialization and the insert part, return value is null, right? So we are just inserting, we are not returning anything here, right? In the simple term, so return value will be null. Now trie has apple, right? So now again, this insert we have considered, right? So trie, this is initialization part, this is also null, this is also null basically, right? Trie with this one, this is nothing but the initialization part, so this is fine, null. So next let's go with the search man, right? So we are done with the apple as well. Now we have to search apple, right? We have to search apple. So we I said you one thing in the question, that for the search method we have to check if the full word exists in the trie or not, right? So here full exact match is found. See, here we have a, we have p, we have p, we have, this is nothing but the l, we have l, and we have e, right? So in that case, I said this one, these two goes with the return value is boolean value, right? For these two, one is for the search and another one is for the starts with, right? So this one search apple, so this is boolean value true, right? So we get the boolean value true because a p p l e, all the letters are present. So next let's go with the search here, search of app, right? So search app, path exists, but this will not be marked as word, right? So because see, we are searching for the entire word, right? So we are just going for the app. So we will one more thing I want to say here is, so we will be marking e as the end word. Always remember this one, we will be marking this e as the end word. And while we are searching, we have to go with the full word actually, apple, and end word will be marked, basically this one e will be marked as an end word. And we will be searching for the app. So app is present in the apple, no doubt, but the end word we didn't get here. So in this case we will be returning false, right? So that is the reason I stressed while explaining the search method, we will be checking if the full word exists in the trie or not. That's what we'll be doing, right? So this is fine, I guess, right? So this is fine. Now we are done with this part. We have got the this one, we have written false, right? So next we'll be going with the starts with, basically starts with app we'll be going with, right? So this starts with app, basically the path exists, right? So here this one, so we'll not be going with the end word, we'll just check whether the prefix exists or not. So again, in the question, what did I say for the this one starts with method? So we'll check if any inserted word starts with a given prefix or not. That's what that's the thing that we'll be doing with the starts with, basically. We'll just check whether app is present, the characters app is present or not in the apple. So it is present here in this case, right? So starts with app, this is true, right? So this is fine. Now we have insert this one, right? So insert of app we have. So again, what we'll do, we have already we have app here, right? So apple, within the apple we already have app. So we will mark this one as word now. So we will mark this one as end word. So apple consists of e end word. So now we have marked two letters as end words. So this is one word in the try, nothing but. So this part, just give me a second here, 1 second. uh now 1 second, yeah. Now we have a 1 second, just give me a second here. I'll just show in this way. A p p so first we had inserted this one, right? So we have done for most of the things now. Yep, we are done till here, right? So null, null, true, false, true we have got here. So this one we are going with the insert, right? Insert of app. So we have marked this one as end word, and this one now we have inserted one more word app. So app is already present in the try. So we'll not insert one more word. This one we will consider this one as word, and this one will mark this one as end word, basically. Now we have two end words. One is p and one is e. Means we have two words basically in the try, that is app and apple, right? So this is fine. uh, this part is also done. Insert, insert of app, this one we got null. So finally we are left with search as well as the app, right? Search app, what we will do, we will search, this time we will search for app as we have the end word p here this time. So this is also considered one complete word. So this time, instead of returning false, unlike the previous, so what we will do, we will go with the true, return value true, meaning here, so we will return true, meaning this is considered as word and p is the end word, and we have found the entire word here. Means we have searched for the app, we have found the entire word. So what we will do, we will return true. So this is how we got the output. Null, uh, null twice, true false, true null true, right? So this is how we got the output. So whatever the output that we got matches the output that they have given for the example one, right? So our approach works absolutely correct. Let's quickly discuss the complexities before writing the code, right? So what would be the time, this one complexities here, time complexity and the space complexity. So the time complexity would be pico of L. So why the time complexity is pico of L here? Sorry, this one L is nothing but the length of the word or prefix, right? So L is nothing but length of the word or prefix, right? So just give me a second here. Or length of the word or prefix. Just keep this in mind, right? So what will be the space complexity here? Space complexity would be big of n into 26. So when I say big of n into 26, so this will be almost equivalent to, so I can just write it like this. So it is almost equivalent to n. So we can just write it here. N, sorry, small n I have considered, right? So this n. So this is nothing but n into 26, which is equivalent to n, nothing but here total characters that we are storing, or total characters that has been stored, right? Each node has 26 possible children, right? So from A to Z, right? We know this one. So the time complexity and the space complexity for the code that we'll be writing in the future would be because of L and because of N respectively, right? So I hope this one, the complexities part is completely clear along with the approach, right? So now as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. First, what we'll do, let's go with the node structure of the trie, nothing but the initialization part here. Let's consider array just to hold the 26 letters that we recently spoke, right? So I'll just go with trie node. This is fine. And this one will be children. So this is also fine. Now, next thing is, let's go with the Boolean value. I'll just go with Boolean is end. This is also fine. Now we are checking true if the word ends here. That is the reason I'm considering the Boolean value is end here. This is fine. Hmm, yep. Now let's do one thing. Here within the trie itself, let me do one thing. I'll just consider trie node here. This is fine. So within the trie node, let's allocate the space for lowercase letters, right? So 26 lowercase letters. I'll just go with children equivalent. So I'm just assigning this one to the this one trie node 26, right? So this is fine. Now let me assign is end to false. So this is also fine, man. I'll just come out of this one entirely. Now let's initially we have to start with the root of the trie. Always in the trie, remember. So we will be starting with the root of the trie. Then comes the children. This one children means then comes a p p l e whatever we have added. First we'll be going with the root of the trie, right? So root is common basically for all the this one words that we insert into the trie. Just remember that one, right? So this is fine. Let me do one thing. I'll just come here. Uh, so this one, just give me a second, man. We have to start, right? So I'll just go with private trie node. So this one, let me assign root. This is fine. Now I'll just consider this one trie node, man. Public trie node, right? So trie node children. So this is fine. Boolean isn't. This is also fine. This is fine. Now let's consider this one main one. Sorry. This is just this was for the trie node basically. Let me copy this one entirely. So I'll just come here. So let me paste this one. So within the trie class, so let's initialize the root node. So I'll just go with root equals new trie node. This is fine. Uh, this is fine, man. Now let's go with the insert method. First thing, let's start from the root. So I'll just go with the trie node. So node equals root. This is fine. Let's go with the for loop here. This one char c word dot to char array. So this is fine. Now within the for loop, so let me go with a simple if condition here. If node dot children, so this one will be index. So this one equivalent to null. So we have to create the node if it is missing, right? So I'll just go with node dot children. So this one of index. Let me assign this one to the let's create instance of the trie node. So I'll just go with new trie node. This is fine. Let's move deeper in the sense. I'll just assign the node to node dot children, the particular index. So I'll just go with the idx. So this is fine, man. We are just moving deeper. The final step is we have to mark the end of the word. Nothing but we are going with a boolean value in this case. I mark that one as end word ew, right? I showed with the ew within the approach. The same thing we are doing with the this with a boolean value. So I'll just write here node dot is end. Let me assign this one to the boolean value true. This is fine. We are done with the insert method. We are left with search and starts with, right? So let's go with the search method now. So in search method, let me go with the initialization part first. Trie node, we have to start with root. We know this one. This is fine. This part is fine. Again, the same this thing. Let me copy this one here. Let me paste it over here. This is also fine. See to what a character. So this is fine. Now let me go with int index equals c hyphen a. This is fine. Now let me go with a simple if condition here. If node dot children, so of index, so this one, if it is equivalent to null, so what I'll do, I'll just return false. So this is nothing but missing path, right? So I'll just do one thing. So I'll just come out of this one entirely. Let's return node dot is end. So this is fine, man. So we are just returning true only if the word end is marked, right? So this is fine. So we are done with this part. Now we are left with the starts with method, right? So finally we are left with the starts with method again. So let me copy this entire line. We have to start with a root. So this is fine. The next part is again the same thing. So instead of the prefix, so just give me a second here. Let me write the for loop and make the necessary changes. So this one, instead of word, so we have the prefix. We will check for the prefix only, right? So I'll just go with prefix dot to carrier instead of the word. So this is fine. Now within the for loop, what shall we do here? We have to search for the prefix, right? So again, so I'll just go with index equals c hyphen a. This is fine. Now let's write the simple if condition. If node dot children, so this one of index, so if it is equivalent to null, then we will return false. So this is fine. This is, we are considering the missing path basically. So if the path is missing, then we have to return false obviously, right? So then let me assign node to node dot children particular index. It's fine, simple. So finally, if the prefix path exists, then we have to return true, right? So I'll just give here return true. This is fine. So yeah, we are done with the so this one starts with method as well. So we are done with the coding part. So finally, I'll just format the code once and let me hit the run button. So I hope this works, man. Let's see. We have the compilation error here. Compile error, sorry. This one invalid method declaration return type required in try.java. So basically, this is in the line 3. First, let's go with line 3. Let's see. Hmm. So I have considered try node here. Oh yeah. So this one I have considered try node, right? So this one I have to go with the class one. Go with the class parenthesis is not required. Basically, this one I have written. So this is fine. Now this has to work. Let's see. I have to go with the class, not the access specifiers. This is fine. Now, cannot find the symbol. If node.children of index line number 22, uh, index, I have not considered index here. Within the this one insert, right? So just give me a second. I give, so I have not initialized the index at all actually. So somewhere I have skipped something, man. So here let me initialize this one. I'll just go with index equals c hyphen a. This is fine. Now this has to work. Let's see. Again, this has to be capital T. Where is it? Line number 24. Yeah, this is fine. Now let me run this one. We have the wrong answer, man. Apple. This is fine. Somewhere we are getting false everywhere instead of the true. So we are getting false everywhere, right? So third one. Wait a second. Search of this one apple. We have to get true itself, right? Search we are performing. So search we have search something wrong. I have done something wrong with the search. So let's go with the search here. This one word. This is fine. Try node. Node I have this one, assign this one to the root. For char C, oh yeah, this one is also fine, right? The search we are going with a word, this is fine. Or to char array, within that one index, this, yeah, this I'm going with a C hyphen, yeah, this is also fine. Not dot children of index within the array. If this is equal to null, then we are returning false, right? So this is also fine. Uh, so yeah, this one have not written. This is the reason we are getting false every time. So I have to assign here node to node dot children of index. So this is the thing I have completely forgotten, right? So that is the reason we were getting error, I think. So now let me run this one. Yeah, now the sample test case is getting passed. Means the code works absolutely correct. Now let me hit the submit button. I hope this works for all the test cases, man. Yeah, this works for all the test cases, right? So whatever the code that we have written works absolutely correct for all the test cases, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.